My name is Carol Wellington, and I am the director of the School of Engineering at Shippensburg University. And I'd like to take some time today to talk about the differences between computer science and software engineering. In most schools, software engineering is one part of a computer science degree. But at SHIP, we believe that software engineering has matured to the point that it warrants its own degree. And that frees our computer science program to focus really well on computer science itself. So it may seem like what we're doing is a little out of the ordinary, but it's really just the way sciences grow. More than 100 years ago, chemistry programs started having individual chemical engineering courses, and eventually that part of the discipline grew up to be its own discipline. So at this point, we see plenty of material that is specific to software engineering to build a full degree that is focused on the industry aspects of computing. And so we have pulled it out into its own degree, just like people pulled chemical engineering out of chemistry. So computer science isn't a physical science, it isn't a natural science, and it isn't a social science. It's what we call a synthetic science. In synthetic sciences, you discover new things by creating them. And when we create something new, we validate it by demonstrating that it is in some way better than the prior solutions to that problem. So when a computer scientist is looking for a solution to a particular problem, the first thing they do is read the existing literature to find similar solutions. And then they propose some improvement to the existing solutions, and then they perform an experiment that demonstrates that their solution is in fact better than the prior solutions in some measurable way. So a solution might be better if it runs faster, if it requires fewer resources on the machine, or if the result that it produces is more accurate. So this means that computer science students need a really strong understanding of the theory of computability and the ways that we measure these aspects of betterness. So the focus of computer science is trying to find new solutions, trying to build things that have never been built before. So the areas that computer science will focus on change over time as different aspects become the cutting edge. These days, the current big areas in computer science would be things like big data and security and artificial intelligence, things where there are really big open-ended questions to explore. So when you look at the computer science curriculum at SHIP, you see that most of the content is based on the ACM guidelines for computing curricula. There's a lot of our program that looks a lot like other computer science programs. But we have two things that are really special and interesting. The first way we're different is that we have a unique capstone. The capstone is the penultimate class of a degree. It's where everything comes together. In most computer science programs, the software engineering component of their degree is the capstone. So their capstone is a team product development course. For our students, we really want them focused on that synthetic science aspect of the discipline. So our capstone is an individual research project in an area that the student chooses to pick, and they do that one-on-one with a faculty member in our department. The other thing that's unique about our computer science curriculum is that it has an interdisciplinary requirement. Most of the time, when a computer scientist is solving a problem, they're solving a problem for somebody outside of the discipline of computer science. So having our students learn about the problems and language that are used in a different discipline prepares them for being able to talk to people outside of our discipline and to solve those people's problems. Now, we do understand that it may be important for some computer science students to have that software engineering experience. There are electives in the computer science program, and the students can choose to use software engineering courses to complete those electives to give them that software engineering experience. So given that definition of computer science, what does that leave for software engineering? Well, what software engineers do is they take all those things that the computer scientists learn and they use them to build systems that people are going to use. And in general, those systems are really big software systems. This means that our software engineering students need a really good foundation in how you design quality, robust software systems. And in addition, they also need an understanding of how teams work together to produce big software systems, so there's a focus on the processes and tools that those teams use. When we talk about design in software engineering, there are external, visible things that we need to design, and there are also internal, kind of invisible things that we need to design. As an analogy, imagine that you were tasked with designing the Freedom Tower. There's some external things that you need to design. You need to understand how people are going to use it and how many bathrooms it needs to have and what it's going to look like from the outside. Those are all visible aspects of design. The same ideas come into play when we design software. We need to think about how our users going to use the system. How do we design it so that it's easy for the users to do what they need to accomplish? Now, when you're designing the Freedom Tower, there's also an invisible aspect to design. There's a whole bunch of things that have to be designed that we never see. So for example, when I'm designing the first floor, I need to put in enough space in a wall somewhere to run enough wires so that I can have enough power at the 100th floor. That's an aspect of the building that you and I will never see, but somebody had to carefully design that. Software engineering has the same thing. We need to design the internal structure of the software in a way that makes it robust and reliable and easy to add new features to it. So while there is an external, how pretty is it, design aspect, there's also this kind of internal structural design aspect to software engineering. The other thing that distinguishes software engineering from computer science is that software engineering is a team sport. If we're going to build really big things, we're going to need other people to help us build them. We're going to need a team of people that have a variety of different areas of expertise that we can put together to build this really big system. In order for that team to function well, we're going to need some standard tools and processes that help us do things like decide what things it is that we're going to build. How are we going to divide it up into pieces and have people work on the different pieces? How are we sure that all of those pieces are going to fit together to produce a quality product on time? How are we going to track our progress? How are we going to make sure that the changes that you make to the code don't mess up the changes that I made to the code? So there's a lot of focus on how the team functions and what tools we can use to make it function well. So historically, software engineering processes have been plan-driven, which means that you plan a release and you work on that plan and it takes you 1.5 years or 2 years to produce something. But our industry is rapidly converting from that plan-driven philosophy to agile processes in order that we'll be able to adapt to the changing needs of our customers. So the software engineering program at Shippensburg is focused on agile development. Our students start learning those agile techniques in the first course that they take. And through our curriculum, they develop a number of large projects on teams using those agile techniques. And that gives them great skills that employers are looking for and great stories to tell on their interviews for jobs. So the software engineering curriculum at Shippensburg starts with those engineering principles in the first programming class. Our software engineering students are engineering students, so they complete the school's engineering core. And then the curriculum is essentially increasingly large design projects. So they start designing smaller things and they design bigger and bigger and bigger things until they get to a system that is too big to fit on one machine and your code is scattered all over the globe. And the software engineering program has 2 product development courses. One where you're building a product from scratch. And in that one, you're really focused on how do you come up with a design from scratch. The second one, you're adding functionality to an existing system that you did not develop. This is an entirely different process because you first have to learn how to read the other people's code and figure out how their big system of software works. And then figure out how to squeeze in the parts that you need to squeeze in to add the functionality that you want to add to the system. So people often ask me which of these programs is better for getting a job. Neither one. Both programs have excellent hiring reputations. There are employers who come and look for students from both of these programs every year. And similarly, students from both of these programs have gone on to graduate schools to get master's degrees and PhDs with equal success. So it isn't that one program is going to prepare you better than another one is. So in picking between these degrees, it really depends on whether you're a scientist or an engineer. Do you want to develop new ways to solve problems that are better and more efficient or more accurate? Or do you want to take those theoretical results and use them to build systems that people use, the things that we depend on every day? So I think this quote from Fred Brooks really gets to the details of it. A scientist builds to study. That means our computer scientists are going to build things, but they're going to build them for the purpose of better understanding things. Where an engineer studies to build, an engineer is going to study all of the things that the computer scientists did for the purpose of being able to build new systems. If you have any questions about this, I'd encourage you to come see us. We have regular open houses, and anytime you're going to be on campus, we can arrange for a tour of our part of campus. But if that doesn't work and you want a faster answer, feel free to email me at engineering@ship.edu. Thanks.